Did you know that tiny invisible defects could bring entire electronic systems to a halt? In today's video, we're diving into the world of conductive anodic filaments, or CAF, and why they're such a nuisance in electronic assemblies. Conductive anodic filaments, or CAF, are tiny, unwanted connections that form between conductors on a circuit board. These conductive paths are created due to moisture and electrical fields, potentially leading to short circuits that can cause serious failures in electronic systems. CAF occurs when moisture seeps into the insulation material of a printed circuit board, or PCB. With an electrical field present, electrochemical reactions occur and metal ions start migrating inside the laminate from the anode towards the cathode, precipitating along the way as metal salts due to pH gradients and creating a filament. Over time, these filaments grow, eventually forming a conductive path that can short out the circuit. The process of CAF formation is relatively simple. First, some kind of defect, maybe from stress, a tiny crack, or delamination of the epoxy from the glass fibers, creates a path within the laminate for the filament. When humidity and voltage are present, metal ions begin traveling along this path. Eventually, these ions precipitate to form a conductive filament between the anode and the cathode. As a side note, remember that although similar, CAF and dendrites are distinct. They are both caused by moisture, electric bias, and electrochemical migration, but the underlying physics are slightly different. Dendrites grow as metal ions are reduced at the cathode, forming a metal filament that grows from the cathode to the anode. CAF, on the other hand, form as metal salts precipitate along this path that grows from the anode to the cathode. This phenomenon is more likely to happen under specific conditions like high humidity, elevated temperatures, or electrical stress. And once CAF takes hold, it can mean big problems for sensitive electronics. Think aerospace, automotive, and military applications. A single CAF event can cause a short circuit, potentially shutting down an entire system or creating critical safety hazards. To reduce an assembly's susceptibility to CAF, there are a few design choices that can be made. First of all, material choice. Remember that CAF needs a path to grow, and if we can do a good job of ensuring that we don't create those paths through excellent adhesion of our board materials, we can reduce those risks. Also, design rules such as via spacing can be incorporated to make sure that high voltage biases are not too close to each other. By designing and manufacturing with these best practices in mind, the risk of CAF can be minimized, leading to safer, more reliable electronics. CAF may be invisible, but its impact on electronics can be massive. By understanding the causes and prevention of CAF, designers and manufacturers can improve reliability in critical applications. Alright, if you like that content, make sure to hit the like button and subscribe. You can also click that bell icon to be notified of future videos. Now, if you have any specific questions about CAF, feel free to leave them in the comments below, or you can send an email to AskDrAdam@Kyzen.com. Thanks again, and stay clean.